So thank you for everyone here. You are still here today to participate to our final sessions in this course. Actually, right, where we will go into the exam, the final exam in next week in the 14th of June, right? And then in order to prepare well for your final examinations, this last lecture will be also integrated to the final exam, so it will be also important to you. So that's why I'm already make a recording to here in this group for everyone. If you miss the class, then you can come back and then review this recording. Okay, by the way, let's come to the our conversation with final lecture as well today here. Okay, so what we are doing on software until now is software is to using our supervised machine learning or supervised learning, which is like we say in about virtual, right? Where we can, what we're doing in this supervised learning is we will have untrained data, right? And this trained data will have some instant. It could be a loss. It could be very little, depending on the problem that we have, data that we can collect from our real works. Then it could be something, if you luckily, and then you can have like more than 10,000 instant, for example. And then we will have some features, raw data, and then it's labeled right. We have like virtual X1, X2, etc. Right. Then we'll have a label at the end, which is like we say, supervised learning. Then based on this kind of level, and then we can have it could be something like we say first of all, like we in the Setosa and iris problem as well, right? We will have some class like Setosa and Veshicolor, Veshinica or something. And then we make we will update our way and how this way will be belongs will depend on will up to the features that we will the dimensions of the feature that we have, right? For example, like if we have two feature and then we can have like two one-dimensional vectors. Then if we have more dimensional vector, and then we can have more dimensional vector as well. And then we will update this, for example, like in two-dimensional, and then we update it in this problem where are you only two, right? And then we can make a prediction on the test data like 1, 2, 2, 1. Then make a prediction by you calculate the sum of this to the some features that we will have here. And then this way will be updates directly to this, and the filter here will be using in this way. And then we say, and okay, here we say to where's the color, say to I think we don't know, but we might have something like this one. And then we can make a prediction about, okay, positive will be vesicular, negative will be positive for substance, negative could be something like vesicular, for example, and that's class something like that thing, right? And then we'll make a prediction on this. Should be should be vesicular based on the way we update it here after we training. So in the case if we won't have any label here, how we can and what we can do with this kind of data. So here, what we saying, okay, I use my supervised machine learning and I can do this kind of thing based on the level that I have, and I can map it to 1 and -1 to binary expression, and update the way that if I have on the features here. And then, for example, like, and if we know the day, actually, we save the data that we collect the day from many kind of device, and we can collect it without label. It's very a lot and very large amount of data that can represent and without any label, and we want to find out, okay, this kind of data was meaningful from this data, what we can make final decision about this kind of data without label will be something that we save more interesting, or actually it will be very hard than the problem that we are dealing with supervised learning here. Right? So here we say something like without label, and then how we can tell a label, and then what we can do with the thing. Now we say actually it will be something like unsupervised supervising methods are learning, actually supervised learning. Yeah. And this kind of data is represented in our real work more often, even is it's in our real work, so, in many games. Yeah, right. Okay, so that's mean in unsupervised learning, what we are going to do in we're dealing with data without any label over there, and we can do something many things that we can do. For example, like we can detect patterns. We say, well, okay, group email similar together, find carrying of the customer, detect anomalous program execution, for example. And normally this kind of data is useful, but we don't know what we need to look in for that thing. And I would just often get gibberish here. Okay, so unsupervised learning, I would say something like clustering, which is same meaning here. Same thing together. I would say clustering, that's something like group some things similar together, right? So how to do that thing? How to do this clustering actually. So the basic idea of this clustering, we say the idea here would be like something like group together similar instance. You know about the instance, right? Which is like we say here, even in our iris data, right? Where you can try to make a clustering on iris data. It's like you can delete some class here. You can delete all the class here. Then try to using this algorithm after we learning about this clustering, and then try to do this with data set as well, and then you can make an experiment at home and to see what the advantage of supervised machine learning we have here and unsupervised, for example. So here we will saying, okay, I will have first instance here, data sample, data points will be here, right? Second here, third here, fourth here, five. And then the basic idea here in clustering is group together similar instance. What does that mean? How I can group this data instance here with this data instance here. It is will be similar or not. And how we can know this instance, for instance here, will be similar to this this first instance here or not. So normally we use something like we say if we have a two dimensional data point, then you should know about something how to calculate the distance between the two points. For example, like if you have like we can project our first data point here. For example, like we take two features here, right? Which is the first and the third here. And then using the Eclipse distance, which is into dimensional, and then you can calculate this with this formula, and then you can know how far from this point, for example, from this point P to Q, using the B1, the source square of Q1 minus 2B1 square plus with the Q2 minus P2 square by this one. Right. Then so in order to group together similar instance, we can use something like Eclipse distance like thing for the clustering, right? So here, in particular in this lectures where I would like to present you or introduce you on K-mean algorithm, which is a very typical and basic clustering algorithm, which is can be used to group together that is similar instance. Yeah. Okay, so let's look to the algorithm K-mean here. So what it's going to do in this K-mean? So in K-mean, it will pick random case, random points at a cluster sensors, let's say the mean here. We can so this will be a cluster sensor cluster sensors with the same meaning. And then for example, like in this data set, we will have many instance here, right? And then they will pick 5 instance here with random points for the main the cluster sensors. And then what they will do is assign data instance to the closest mean. For example, like we say here in this area, right? This data will belong to this first cluster choice here, right? Say first here, in 7, 3, 4, 5. And this area will be we don't know. We need to calculate the Eclipse distance to this central, and then we will know this data will belong to this or will belong to this thing. But we can show around here this area which should be belong to this one, and this data point here will be belong to here. Around here will belong to here. Around here belong to here, and here it should be we can confidently say this data point will belong to this choice. And then what it doing, it will assign its mean to the average of the assigned point. Yeah, we will have an example exercise to do this thing. So don't worry if you couldn't understand this right now, right? And then after it's doing updated thing here, and then it will stop when not point assignment change. Okay. So here we have an visualizations how actually after it's update the mean, and then how the mean will be going from another location, this location to another location like this one. Okay. Here we can say from directions of how this algorithm will be changing. Okay, so what we need to do in k-mean, how we can optimize the k-means is where something we need to consider is the point, the assignments, and the mean, right? Then it's on based on the Euclid distance to make this sum. Then we need to do two things: update the mean, update the assignments. So here to update the assignments, we will have something like we will have an example about to do how we can update the mean and how we can update the assignment here with this simple example. So let's take a look on this simple example where we will have like the data set we will have like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 data point here. It's a very simple example, right? To make us more understandable, okay, how actually k-mean we're working with this algorithm with this kind of data. So so as you still remember, we curve to cluster strength choice here, which is like C1 and C2 randomly, right? So in this case, we choose C1 will be belong to this point, and C2 will be belong to this data point here. And then we will go into look on the data point here to its central class choice here, right? So we need to calculate. So first we go into the first data point here. Then we will see if how we can calculate this Euclid distance, which will be equal to the square root of. Here we will have like first data point here with x1 will be 5, right? So we can have 5 minus the central here will be 5, right? Square plus which here will be something 3 minus 3 here. So that's why. Right now we can have the distance right now will be equal to 0. That means this level will be exactly lie on this kind of glass junctions, right? See one. Okay, sorry. And then we need to calculate this point, data point to this C2, right? So that means we need to calculate the Euclid distance from this data point to this central C2 here. So that means we can do something like 10 or 5 minus 10 or 10 minus 5, right? Square. And then last with 15 here, right? Then minus with 3 here. Then we can have this will equal to square root of 5 square, right? 5 over 2 plus with here will be tells over 2. Okay. Then this will be equal to 15, no 13, sorry. Okay. So that means, and then we need to compare this one to 0. So that means after we calculate this, that first data point to the central C1 and C2, right? And we will choosing the one how we can assign this data point to this C1 or C2 by choosing the one who have the Euclid distance smallest one. So that means this data point will be closer to this C1 than C2, right? So that's why right now we can assign our data point to this cluster will be C1, right? So again, first we go into first data point, right? Then we go into the second data point, and then we can have the same thing here. And then we see if this data point will have how far is from C1 will be 13 and to C2 will be 0. So that's why this data point should be assigned to the cluster C2. And then we go into the next one, right? And then we will have a collect distance for C1 of this data point will be 13.45, and C2 will be like 5.83. And so we have conclusion. This data point should belong to C2 because it will have smaller distance from this data point to the central C2 here. And again, we can have and then compute this one. So we see that's on the value here. For on the point data point here, right? And then smaller than the value here of the C1. So that means on the data point here should be assigned to this cluster C2, right? Then we can so here the first thing that we say in K-mini update assignments, right? How we say how we can update our data point to that assignment. Then we will have 9 data point here belong to the C2, right? Cluster, right? And here we have for one data point here will belong to the C1. So that means the next thing we need to do in K-mini after we update assignment, we need to update the mean here. There are two phases in that thing, right? K-mean optimizations. Injection is update the assignment, then update the mean here. So how we can update the mean? Yeah. So here we in this example where we have here our point we only see one, so we only have C1 in one point, and we don't need to to update the mean because the mean here one point is still aligning on it. But here where we have 9 point here we belong to C2. So we need to update our mean our cluster central C2 within the 9 points here. So in order to do that thing, then we need to calculate the x of x of all their 9 data points together and divide it by the on the data point number of data point here, right? Then the y coordinates, which is here and divide by the number of 9 data point here, and then we will have at the end the new cluster choice. The mean will be like value this in this 47.77 and 50.33, right? Okay. So again, we need to update because in this algorithm is saying in what to this coming is saying we will stop it when no point assignment change. Yeah. So let's take a look to this example where we're saying our assignment here in this case it will changing. So that means we need to update the assignment again, and we need to update our cluster centroids again as well, right? Okay. So in order to do that, we do the same thing as this first iterations, right? We're going to compute this data point to this centroid again. Then we'll have 0 and calculate this one, and then we'll have here will be city trees, and then we make a decision. Okay, it should belong to C1. And then we calculate this second data point with the change choice, and we got it 13. And we calculate this data point to the C2, and then we see that this should be smaller value. So we assign this data point to C1. So we update the assignment right now, right? So again and again, we can with this iteration, and then we can have our C1 right now. We will have for data point will belong to this, and then we have for the data point here, and then data point here will belong to the C2, right? We belong to C2 here, and so that means we need to update the mean here again for data point, and this and the central our cluster central here for this data point here again. So we can make the sum here and divide by this one, and then we have a new data point mean here, and then with this data point here, and then we can have a new mean here as well. And then again with this iteration trees, and then we can update, and then we will have 5 data point will belong to C1, and 5 data point here will belong to C2, right? And then we calculate the mean again, right? With this further data point, and then we can have the new one here, like this one. Okay, so and then in iteration 4, iterations 4, we will have our here is still 5. Data point here will belong to C1, and here still 5. Data point will belong to C2. So that means we won't change anything here anymore, right? So that means we can based on the rule, then we can stop our algorithm here. And when we take a look on the mean, and then we see the mean in iterations 4 trees, and the mean in the iterations 4 will be the same here. With this sitting boy 8 and 17 and 72 and 74, the same thing, and they now change in the assignment anymore, right? And then we can right now same our algorithm will be we can stop and make our decision at the end, which is like we will have find this data point should be belong to something we say class C1 or C2 star, for example, like this thing. And this 5 instance should be belong to the class like vesicle or something. Yeah, like that. Okay. Okay. So here the end of this also the end of our course as well. With this exam we finish everything, and next week will be our final exam, and good luck for your final exam. So yep. I know.
Teacher, how about the structure of the final exam?
Yes. Let's look. I was saying about this thing. Okay, our final exam will be here. That we're saying in the contents. Okay, I need to upload the file today. This will be on classrooms. So this final exam will be including 3 lectures. Which is the lectures 5, 6, and 7. Okay. And in this 5 lectures, no, in these 3 lectures, you only have the exercise to do in for the final exam. For example, like in Bashoshan, right? Then you will have some. I need to give you this one as well. Look like what we are doing with exercise Bashoshan. Which is we are already going to do that thing. Yeah, look like this one. Oh, what happened here? That's okay. So actually, to give you correct one exercise. Why is not saying anything? The size. Description. Let me take a look from this. It's not really this one. Okay. So here you have my solution on this problem, right? I'm going to fix the problem. That's why I couldn't give you a solution here, where actually it should be here. But it's look the format for exercise will be something like this one, right? Perception like this one, and for the clusterings, then we will have some exercise look like this one as well. Like so this will be important for you to to make it again, to redo it again with smaller, or even in, like, to make it again and again, to deeply understand, okay, what the exercise here I'm going to do, and it will be very useful with the two exercise. It will somehow it will be very similar to the final exam. So believe flow to this exercise, and then it will be very good for you actually. And another lectures which is like here in resonance under uncertainty, right? Then some exercise here will also will be very useful as well here as well, right? To be recover review or revise again with some exercise here, and then you can perfectly to prepare yourself to the final exam. Okay, any other questions related to the final exam? For example, like you don't know when and where, or even somehow, I don't know. Any question, then I can give you an answer that we hear. Yeah, it's still open note, and you can open. Yeah, so here you can print anything here to the exam with the notes here, right? Then you can print it down and then bring it to the exam. Of course, we couldn't bring our laptop to the exam. Any other questions? Sorry. Okay, if you don't have any questions, then we can stop our lecture today here. And I wish you prepare well everything for your exam, right? I will try to fix the problem with the platform why couldn't save my solution here to send to you to the platform. Then I will upload this here. Yeah, I will try to do this again. This one, fix this problem. But you need to do from the exercise on clustering, right? Where we're doing with this simple example is we have here. Try to do this at home to prepare yourself for the exam. And also here, where we saying about something like that, there are probabilities here. Then yeah, we will have three parts with three letters like this one. And yeah. Everything clear, everybody? Okay, so thank you so much for your attention today and for your attention to my course to on the what we explore and learn anything during this course. And I wish you on the pass and can pass this course, which is no obstacle and difficulties. And have a good day, everyone, and good luck for the exam. And see you soon. Okay, bye-bye. Yeah.